Hello, everyone. Welcome to Approach to GMAT Questions segment. My name is Joshua Ubuya, a GMAT trainer and coach with the Kenya ELIT program. We'll bring you questions that are from the GMAT exams and show you how you can approach them in both quant and verbal sections. You check out our other videos to find out more. In this session, we're going to look at counting methods in GMAT. We're going to focus on problem-solving side of it. We also have a data sufficiency side, which also video is out. And if you haven't watched it, you can check it out. We also will be releasing other topics, so keep in touch and watch. Just before we take a look at the questions themselves, I would like to mention that this counting methods section is one of the sections that pose a challenge to many students. And mastering it will enable you to be able to go to higher ranks, if I may say, for lack of a better word, to go to actually be able to answer higher difficulty questions in the GMAT exam. And nonetheless, not so many of them do tend to appear in the exam, but still, if they do appear, then either you are doing well or you may not be doing so well. So let's dive in and look at some of the questions. The questions we'll be looking at will be across all difficulty, and therefore we just want to see how do you approach such a question if we come across them. So here's the first question. Pause the video for about 2 minutes, answer it, then come back and take a look at how to approach it. So John, who lives in city X, plans to visit 3 cities, M, L, and S. He plans to visit each city exactly once and return to city X after the 3 visits. He can visit the cities in any order. In how many different orders can he visit the 3 cities? Yeah. So this is considered an easy question. It's a sub 550 level kind of question. And from the logic that you can see about this is that actually go from actually move from X, then go to M, L, S, L, S, M, M, S, L, and so on and so forth. So we can actually either you can write down the various steps that actually can be taken that he can actually use to visit, or you can actually go ahead and use a formula to answer this question. Yeah. So this is actually being a question asking in how many ways can he visit the 3 cities in no given order. Yeah, and there's nothing to be picked out. Since the 3 options, he can actually be able to visit them in 3 factorial ways. Yeah, this is actually 3 times 2 times 1, which is 6 ways. Yeah, so this actually the correct answer for this is choice B, B as in boy. So he can visit the 3 cities in 6 different ways. So if you didn't know how to approach it, this is how to approach it. The other option also, which is long and will take much of your time, is listing them down, but that's not efficient in an exam situation. Okay, let's take a look at the next question. You can pause the video, take a minute, 2 minutes, respond to it, then unpause the video, and actually we can solve it together. A certain company has 18 qualified applicants for 4 positions. How many different groups of 4 applicants can be chosen by the company to fill the positions if the order of selection does not matter? This question asks, in how many ways can you select a group of 4 people from a larger group of 18 people? Whenever you see a question that actually talks of selection of members from a larger group, that's basically asking you about the combination type of question. Yeah, so that's the approach you need to give to it. So this is actually looking at the formula, which the operation will be NCK, yeah, of which N is a larger value than K, the larger group, and K is a smaller group to be selected. So in this one also, actually, if you look at it, we have selecting 4 applicants from 18 qualified applicants. So that is 18 combination 4. Yeah. So if you can actually be able to translate this one, then you can have your answer. This is also not a very difficult question. It's more or less a sub 550 difficult questions. And these kind of questions, as I have said before in other videos, is that they don't really require so much logic to be able to answer them. They don't really require a combination of knowledge from various topics. Just the topic being tested, if you are conversant with that concept, the concepts of that topic, you should be good enough to be able to answer the question. So let's go ahead and respond to this. So 18 combination 4, that is actually the formula for combination is n factorial all over k factorial multiplied by n minus k factorial. In this case, we'll have 18 factorial all over k factorial, which is 4 factorial, times n minus k, which is 14 factorial. Yeah, 18 minus 4, get 14. So let's solve for this. This actually will translate to 18 times 17 times 16 times 15 times 14 factorial. Yeah. Then again, also we'll have 4 times 3 times 2 times 1, which won't change the value, then times 14 factorial. So the reason why also don't just rewrite yes, because they'll cancel out. They'll cancel out. So what you have is that 4 times 3, 4 will actually, 4 times 3 times 2, can we simplify this further? We have actually, let's see. We have 4 will go here once, 4 will go here 4 times, 2 will go here once, 2 will go here twice, and then 3 will go here once, 3 will go here 5 times. So we have 18 times 17 times 10, which is 2 times 5. So solving for this, 18 times 17 gives you 306 times 10. Gives you, that is 60 ways of picking four applicants out of the larger group of 18 applicants. That is choice key. Yeah. So now this is actually how you will get to see easy questions. In the last 2 questions I've looked at, this is actually how you will get to see easy questions. They just require a knowledge of what formula is to be applied. Once you know the formula to be applied, you just interpret actually convert the question into and plug in the values to the right positions and solve for it, and you should get your answer. As you go higher and get more difficult questions, then actually you get to be asked now questions which will combine multiple topics. It could be more than one, and also could require some logic to be able to solve the question. Yeah. Let's look at the next question. Yeah. A 3-digit positive integer consists of non-zero digits. If exactly 2 digits are the same, how many such digits are possible? Yeah. So once again, also invite you to pause the video, attempt this question, then you can come back and see how to solve it.
You're watching Success with Bob Mwiti Show, presented to you by Appstech America. Appstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.appstechamerica.com. Appstech America, we wake you up to the unlimited potential within you.
This question we asked, in how many different ways can you have a 3-digit positive integer in which 2 of the digits are the same? That is what we're being asked in this question. So we have 3 positions in 3-digit integer. And here actually we're looking at the digits actually being non-zero. So we're looking at from 1 to 9. So 0 isn't there. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yeah. These are 9 digits in total. So 9 digits. So you have 9 digits to pick from, 2 of which have to be exactly the same. Yeah. So if actually look at that, the logic is that you need to have numbers in the form of x, y, x. That is the first and the second digit are similar. The first and the last digit can be similar. The middle one not similar to the rest. So x, y, x. Then you can also have the second, the last digit being similar, and the last one not, the first one being different. So you have Y, X, X. So these are the three different forms that you can have a three-digit integer that we're being asked to find, calculate, and find. So first, let's look at in how many different ways, if you can find the ways in which you can express the first form of it, we just multiply that by 3 because it can exist in 3 different forms. That is the shortcut that you can get from the logic that you can get to this and be able to apply and get your answer. So we have, for instance, if the first digit is picked from this group of values from 1 to 9, we have 9 options of picking this digit. Yeah. If you have one, if you actually pick the first digit, if the next digit has to be exactly the same, we only have one option of picking it because you can't pick a different other number. If you pick 1, the next digit has to be 1. If you pick 2, it has to be 2. And therefore, from this on now, the other one has to be different. Out of the 9 digits, we only have 8 digits to pick from. So this will be 8. So the number of ways in which you can have a digit, a 3-digit number for the first iteration, in which 2 of them are similar, that is in which the first and the second position are similar, is what? 9 times 1 times 8, which is 72. And the same thing, we can repeat the same order will repeat itself for the second, the third iterations we're looking at. And therefore, we just multiply this by 3. Yeah. If you multiply this by 3, you get, that will be 6, then 21, 216, which is choice C. Yeah. So we're seeing that in this case, there's a bit of logic. Yes, you're supposed to know how to actually be able to find the number of times and digits can be selected. But then again, also there's a logic involved in being able to find the number of iterations that will be required to be able to get the total number of digits that can be found. So that is now would make this, that makes this question to qualify for a 600 to a 700 level question. Yeah. Though it will be a weak 600 if that would be the case in my judgment. But nonetheless, still, that is what we look at. Yeah. So also, let's take a look at now a digit that, okay, now one also which could be in the same category, but more or less like a strong 600 level question. This is a question which could overlap. And this one requires quite some logic and possibly also being able to incorporate 2 or more concepts. So all of the stocks on the over-the-counter market are designated by either a 4-letter or a 5-letter code that is created by using 26 letters of the alphabet. Which of the following gives the maximum number of different stocks that can be designated with these codes? Yeah. So you can pause the video, jump to this question, then come back and see how to respond to it. Yeah. Okay, now this question, it could look a bit difficult, but in actual sense, it's not as difficult. Yeah. Given the approach you've had in the previous question, that is the same approach that can be used in this. And just a difference in how the logic is applied. That is just all that makes the difference between these 2 questions. So given that we have 26 letters to pick from, and we have either 4 or 5 options that are spaces to be filled to have a code for a stock on the counter. So you have it either this is 1, 2, 3, 4, or 5 spaces to be filled. 1, 2, 3, 4, 5. So to find the total number of stocks that can be, the maximum number of different stocks that can be designated with the codes, you have to put into consideration both the 4-letter and the 5-letter kind of stocks. So here we go, actually, and we have either 4 or 5. And you need to, in logic operations, when you see OR, we add them. Yeah. When you see AND, that means you multiply them. So that's what this logical operation means in this case. So since there are no other restrictions in actually what these letters can be, the first position can take all the 26 letters of the alphabet. It can be 26 them. Yeah. The second position can also take 26. The third position can take 26. The fourth position can take 26 possible values. So once you get the spaces, you just multiply them because you can have this and that and that and that. So that's what we're looking at. Either the first digit and the second, so it's a combination of them. Given and the operation becomes multiplication. So multiply like that. So this becomes 26 raised to power 4. And since here we have 26, which will be 5 times, because there is no restriction that no digit can't be repeated, we can repeat all of them. It's going to be 26 5 times. So you're going to have 26 raised to power 4 plus 26 raised to power 5. That's what you're looking at. And if you look at the answer choices, you only have them in 2 formats and only 1 power form. How do you simplify these two? That if you look at again, now this now comes to the algebraic scales, knowledge of being able to factor in values. And that is also one skill that also helps to reduce this term to a simpler term. So you'll have 26 raised to power 4, which is common in both these digits, power 4 and power 5. And then this will go into 26 into 1, rather. Let me just erase that. Yeah, just 1. So then back to the pen. So 26 raised to power 4 in bracket will have 1 plus again 26. Because if you add the powers, we should have 26 raised to power 5 and 26 raised to power 4 outside. So this is what we have actually when we reduce this term. This reduces to 26 raised to power 4 times 27, since 26 plus 1 is 27. This translates to 27 times 26 raised to power 4. So if you look at this in the choice says only 27, 26, then raised to power 4. 26 is the one which is raised to power 4, so the answer choice is C. Yeah, so 27 times 26 raised to power 4. 6 raised to power 4. Yeah, that is what you have. So the answer choice is C. So these are normally the questions the type of questions which could be viewed as actually difficult. And it can also get more difficult maybe now if you combine with other concepts like probability. And that's now what makes a 700 level question difficult, because you need to combine logic and also 2 or 3 different topics in one question to be able to get the correct answer. So these references are how you can approach the questions on counting methods. These are some of them. Should you have any questions which maybe you would like us to tackle, kindly post them in the comments below. And also, if you found this useful, feel free to share it with anybody else. At the same time, also check out our training program. And should you need help with actually tackling a GMAT exam, we are here to help. So that's it, and thank you. And bye-bye. See you next time. Hello.
You've been watching Success with Bob Mwiti Show, brought to you by Appstech America. Come back next time to hear more steps and missteps that I took on the path to becoming a successful immigrant in USA. Be sure to subscribe to my YouTube channel and also follow me on Facebook, Instagram, Twitter, and LinkedIn.